Hello Year 11 and welcome to our 9th video here for our 10th topic, measurement. Today we're looking at volume and surface area of a cylinder. In our previous video we were looking at the volume and surface area of a prism, and really a cylinder is just a very special type of prism, a circular prism if you like. The only thing really I think here that's significantly different is when I said to calculate the surface area of a prism, I said that you need to calculate the area of each of the faces and add them together. And that's still true for a cylinder. It's just that a cylinder has a curved face, when previously we have been looking at prisms that have flat faces or planar faces. So we're going to begin here with volume of a cylinder. And I said the volume of a prism is area times height. And that's true for a cylinder as well, but we might just write it as pi r squared h because the area is pi r squared. So pi r squared h, easy enough. The surface area. Now sometimes we talk about open or open at one end or closed. Let's just stick with closed cylinders for the time being. A cylinder will have three faces, a circle at the top and a circle at the bottom. And then I have this curved face. Now, if I was to cut that down its side and lay it out flat, I would have a rectangle. Think of the wrapper on a can of baked beans. Okay, that's a rectangle. Now, the height of that, that's fine. That's likely to be provided to us as a dimension. But how wide is that rectangle? Well, it wraps all the way around the can, which is the same. That distance all the way around the can is the circumference of the circle. The circumference, twinkle twinkle little star, circumference equals 2 pi r. So the area of that rectangle is 2 pi r h. And I've got two circles which are pi r squared each. So that brings me to my surface area of 2 pi r squared plus 2 pi r h. Surface area of a closed cylinder. Now if I say I have a cylinder that is open at one end, then I take one of my circles off, and it's pi r squared plus 2 pi r h. If my cylinder is open at both ends, then I just have that curved, or that rectangle that's been wrapped around, and that's just surface area then, 2 pi r h. We'll see a variety of those questions to work through the exercise, but here in my example 17, I have a can of tomatoes. I want to work out the capacity of this can and the surface area. Right, that's going to be of the closed can. So here we go. First of all, the capacity, we're going to work out the volume first and convert that to capacity, remembering 1 cubic centimetre equals 1 milliliter. So maybe it helps to draw a picture. I always think it does. Here is my can of tomatoes. Should I draw a little tomato here? All right, there's my can of tomatoes. Yep. It has a diameter of 12. Now, sort of the reason that I did this, I suppose, is to remind myself that, whoa, that's a diameter of 12, therefore the radius equals 6 centimeters. Be so careful. You will often get a dimension of a diameter, not a radius, which is what we need. And then my height is 15. That's straightforward enough. Okay, but I like to have a diagram there. Now I have a diagram. It's reminded me the radius is 6, the height is 15. So my volume is, remember, it's pi r squared, pi times r squared. That's 6 squared, pi r squared times the height of 15. Okay, so the volume is 1,696 cubic centimeters. 1,696 cubic centimeters, and I'm just going to say equals 1,696 milliliters to the nearest milliliter, which is somewhere between 1.5 and 2 liters. Now the surface area of the can. We've got our diagram. I don't need another one. My surface area is 2 times pi times r squared, that's 6 squared, plus 2 times pi times my radius of 6 times my height of 15. Okay, now that goes into the calculator. Okay, so that's about 792 square centimeters to the nearest square centimeter. 792 square centimeters. There we go. Volume and capacity volume and surface area of a cylinder. Okay, area times height, volume of a prism. So for a cylinder, pi r squared h. Surface area, 2 pi r squared, that's the circle on the top and the bottom, that's why there's 2 of them, plus 2 pi r, the circumference, times the height. 2 pi r squared plus 2 pi r h for a closed cylinder. Remember, take 1 or 2 circles off if we're dealing with a cylinder that is open at one or both ends. Okay, that's it for this one. If you've got any questions, jot them down, ask me in class. See you then.